Welcome to All This Math. This is Professor Parker, and today we're going to graph a linear equation. So check this out. We're going to graph y equals negative 5/3 x plus 4. Now, how do I know this is a linear equation? Because I know I just threw that term out there. I know it's a linear equation because when I look at my variables, the exponents are 1. Now, how do I know that the exponents are 1? I know the exponents are 1 because there's no exponent written, right? So when there's no exponent written, we just assume that, or we don't even have to assume, we know it's implied that the exponent is 1. So this is really x to the first power. This is y to the first power. So this is a linear equation. Now, because it's a linear equation, the graph is going to be a straight line. The root word of the word linear is line, L-I-N-E, line. All right. Now, how do I graph this? Whenever you're confronted with a linear equation, you need to ask yourself a couple questions. The first question is, what form is this equation in? Right? So you want to say, what form is it in? Right? Now, what does that mean? What I mean by what form? It could be y equals mx plus b. That's called the slope-intercept form, right? Or it could be in standard form, ax plus by equals c, right? Those are the two main forms that you're going to see linear equations written in. One of these two, right? So what you got to ask yourself is, okay, which form is this equation in? Does it look like the standard form, or does it look like slope-intercept form, all right? And that matters because that's going to affect how we're going to find our 2 points we need, our minimum 2 points we need to draw our line, all right? Now, I look at this and I'm like, okay, well, that's a y and that's a y. That's an equal sign. That's an equal sign. That's an m. And then I see a negative 5/3. So that's a number. I see an x and that's an x. I see a plus sign and that's a plus sign. Even though it's not always going to be a plus sign right there, it could be a negative sign right there, right? That's a b and that's a number. So this is slope-intercept form, right? It's not standard form. I don't see a number times x plus a number times y equal to another number. I don't see that. That's not what we got up here, all right? So this is slope-intercept form. So because it's slope-intercept form, there's two pieces of critical information in the equation that I'm going to use in order to draw my line. The first piece of information is called the y-intercept, hence the name slope-intercept form. I see from looking right at the equation what the y-intercept is and also what the slope of the line is, right? So we got 4 and we got negative 5/3. Now, this right here is my y-intercept. That means that's the value of y when the line crosses this right here. This y-axis. This is my y-axis. This is my x-axis, horizontal. This is my y-axis, vertical. So when that line crosses this y-axis, this is where it's going to cross at positive 4. Not negative 4, but at positive 4, right? And of course, the positive numbers are above the x-axis. All right. Now, this right here is called my slope. The slope basically tells you how slanted or flat the line is or is not going to be. And the slope also is a set of instructions as to how to get from the first point, which will be my y-intercept, to the second point. That's what the slope tells me. The slope is not a point. A lot of students get that twisted. They think the slope is a point. The slope is not a point. The slope tells you how to get from a point to the next point, right? Think of it like this. The y-intercept is like an address. It could be your address, right? The slope tells you how to get to where you try and go to, right? The slope is not the address of the next place. The slope just tells you how to get to the next address. The next address will be the coordinates of the next point that you find after you use the slope. All right, so check this out. We got our two pieces of information, our y-intercept and our slope. How do we use the y-intercept? Like I alluded to earlier, you go to the y-axis and you find positive 4. So this is 0, 0, right? Where the two axes meet each other and cross or intersect. And I go to positive 4. Now, positive 4 is not down. Positive 4 is up. So you just count 1, 2, 3, 4. And then you draw your point. That's your first point. Now, the question you always should be asking yourself is, or when you're graphing these linear equations, is how do I get my 2 points? How do I get my 2 points? Some teachers ask for a minimum 3 points. That's cool. You could do that, right? We can use this same method to find 3 points. We can use this method to find 2 points. You find your first point by just using the y-intercept. because that's where the line is going to cross the y-axis, right? This is the y-intercept. This is the y-intercept. This point right here on the y-axis at +4. Next thing, write this down. What is the slope? The slope we already said was -5/3, but we got to be careful. Whenever you have a negative slope, you got to be real careful. Because watch this. This fraction is negative, right? Now the slope is made of two parts. It has a numerator and a denominator, right? So one of the components of the slope is a piece of information that tells you how the line moves, how the points move vertically, right? Also how you should move horizontally to get to the next point, right? So the question you should be asking is, how do I know which of these numbers should be negative? If the fraction is negative, that means that either the numerator or the denominator is actually, if I want to be technical, either the numerator or the denominator is negative, and also at the same time, either the numerator or the denominator is positive. Basically meaning one of your numbers got to be negative and one of your numbers got to be positive. That's why the whole fraction is negative. So what I usually do is this. I treat the numerator like it's negative, and I treat the denominator like it's positive. That's just what I do. Now, you could also treat the numerator like it's positive and treat the denominator like it's negative. Either way, right? Now, some people might say, well, won't you get a different answer if you do that? Well, no, you'll get different points, but you'll get the same line, right? You'll get a different point, but you'll get the same line. I'm going to refer back to that once we actually draw the line. All right, so now, if I do this, and I got -5 in my numerator tells me how far I should move up and down, and whether I should move up or down. Because the numerator is negative, that means I'm going to move down. So what I like to do is draw an arrow pointing down, which will remind me that from my y-intercept, I need to move down. Not up, but down, right? And I recommend you do the same thing on your papers. When you have your slope written down, if your numerator is negative, draw a down arrow. If your numerator was positive, you would draw up arrow. I highly recommend you do that, right? Because that gives you less to think about, because all you have to do is just look on your paper and see what you wrote. Because you're dealing with the instructions. Now, we have a +3 in our denominator. Now, because it's positive, that means I'm moving to the right. So with the positive numbers, right, on the x-axis, the negative numbers on the x-axis are to the left. Because this is positive, I'm moving to the right. So I like to draw a right arrow, a right-facing arrow, right? All right, so now I got my y-intercept right here, and I got my directions. My slope is my directions. My slope is going to tell me how to get to my next point. So I go from here. Let me switch back to the green. Keep things consistent in here. All right. So I go from here, and I go down 5. 1, 2, 3, 4, 5. I don't stop there, though. That's not where I stop. I go there, but then I also got to go 3 units to the right. So then I go 1, 2, 3. And that's where I stop. And now I got my second point. And once I got my second point, now I could draw my line. All right. Now I'm going to just do a quick and dirty drawing like that. Yeah. Not going to break out the ruler or nothing to save time. But yeah. So you see how the line goes down? Now, imagine if I'd have did my slope like this. If I'd instead made the numerator positive and the denominator negative, right? What would have happened was I would have still started at the y-intercept. But if I make my numerator positive and my denominator negative, now I'm going up 5 and to the left 3. And look what's going to happen. I'm going to still end up on the same line. The point that I drew would have been on the same line. So if you're wondering like, okay, well, won't it make a difference if I make my numerator negative or my denominator negative? Won't it make a difference? It will make a difference, but it won't change your answer. It will not change the nature of your line, right? It's the same line. You'll have a different 2 points or a different second point, but you're going to have the same line. And that's cool as long as you got the same line. All right. So this is just a little something light about how to graph a linear equation. Another day I'll do a video and we'll do an example in standard form. All right. So a couple things I want you to remember and take away from here. Identify the 2 questions you got to ask yourself. What form, that's the first question, what form is the linear equation in? Is it in slope-intercept form, y equals mx plus b? Or is it in standard form, ax plus by equals c? Which one is it in, right? Sometimes it might not look exactly like either of those forms, and you might have to do some manipulation in order to get it to look like one of these two forms, right? That happens sometimes too. But when it's in slope-intercept form, identify your y-intercept, plot that, find it on the y-axis, draw that point, plot it. Then you use the slope as a set of directions to take you to the next point, because you need a minimum of 2 points. And then once you got your 2 points, just draw your line and you're done. Ain't much to it, you know what I'm saying? But you got to just do practice. You got to practice these over and over again, because it's easy for me to talk, you know, about this real fluently, because I've done literally thousands of these problems over the years, right? You got to do a lot of practice. Once you do a lot of practice, then you'll be able to just real easily just know from like almost like kinesthetic memory, or what some people call muscle memory. You'll just know what to do as soon as you look at the problem on the paper, and it'll be light, won't be intimidating, and you'll just, you know, be able to rock out and do your thing. All right, but as usual, please like the video. Please subscribe to the page if you haven't already. Share the video, send it out, let people know about it. Let people know what we're doing over here at All This Math. We're trying to combat the issues with mathematics, understanding mathematics education going on in the classrooms all across the country, all across the world. If you're not learning in your classroom, come here. I'm gonna teach you. You could just learn from me. It's all good. And always remember that there's all this math all around you.